Unit 8, video number 7, and this page does not have a page number, so you want to turn to the page, probably page number 8, where it says number 3, single replacement reactions at the top. Single replacement reaction, one element replaces another element that's part of a compound. So, for example, here you have a single element, and then here you have BC, which is a compound. The A and the B are going to switch places, and the B becomes the single element, and instead of it being BC, it's going to become AC. And so those are going to be your products. So you want to switch the A and the B. So in this case, you have potassium and you have magnesium, and so they are going to switch places. Magnesium will become the single element, and then the K is going to take the place of Mg, and it's going to become KBr. So you have KBr plus Mg. You're going to notice that we have our subscripts after balancing charges, and then we have a coefficient after balancing the equation. Taking the products of single replacement reactions, the positive cations will replace one another, or you're going to have negative replace negative. The negatives are always going to be halogens. So if your single element's a halogen, it's going to replace another halogen. If your single element is a metal, it's going to replace another metal. So whether or not a metal will displace another metal depends on its reactivity. Reactivity. A metal must be more reactive to kick out another metal. If it is not, there is no reaction. And often we'll just write this as NR, no reaction occurs. So we have what's given to us is called an activity series, and at the top is the most active or most reactive metals, and then they get less and less active as we go down below. Metals will only replace metals if the other metal is lower than it in the list. A nonmetal can also replace another nonmetal from a compound. This is usually a halogen though. So this is usually limited to the halogen group. The activity of halogens is going to decrease as you go down the column on the periodic table. So fluorine is more active than iodine. So fluorine is going to be the most active, and then iodine is at the bottom. It's going to be the least. It goes fluorine, chlorine, bromine, and iodine. And this is increasing reactivity, just like it says over here, increasing activity. Okay, so let's understand what this activity series means a little bit more. The more active metals is kind of like the boyfriend that is really active. They get you presents, they clean the house, they take you out to dinner, they plan things to do together, and they're just very active. And then the lower you get on the list, they are less active. So they sit on the couch and eat pizza and play video games, and they feel like I love you is sufficient to then getting you presents, like oh, you don't need a present, just I love you should be good enough. They don't like to go out anywhere, they just want to sit at home, they don't clean anything, so not very active. But the higher up on the list, very active. So that being said, elements prefer to be with more active metals, because wouldn't you prefer that? So let's look at example number 1. Here's the activity series over here, and we want to find zinc versus hydrogen. And so if you'll notice, zinc is here and hydrogen is below it. So since zinc is higher up on the list, I'm going to give it a smiley face. And because hydrogen is lower on the list, it's going to get a frowny face. And then I'm going to put a star here because SO4, sulfate, is the star. They want to pick the metal that they want to be with. Star wants to be with the smiley face. So that means that zinc is going to switch spots because sulfate's going to kick out hydrogen and take in the zinc. So we're going to move hydrogen to be the single element. Notice that I am not carrying forward this little 2 here, even though it's going to get a 2, but we're not going to carry it forward because it's here. And so I'm going to put a plus because hydrogen is now the single element. Now here's my plus, and now instead of hydrogen, we're going to put the zinc in this spot, and it's going to be zinc with the sulfate. Zinc and sulfate. Now, you have to balance the charges. Let me get that out of the way. We need to find the subscripts for everything. Let's start with hydrogen. It's a single element, so the only question is, since it's a single element, is it one of the 7 diatomics? Hydrogen is, therefore it needs a subscript of 2. Now we're going to balance the charges on zinc sulfate. So I'm going to put zinc sulfate here somewhere separate because I don't want to mess up my equation. And so on our reference page, we'll look for zinc, which is a +2 charge. So +2 on zinc. And then SO4 is a polyatomic ion. And so I should look on my list of polyatomic ions. Go to the bottom. Here's sulfate, SO4, -2 charge is what I'm looking for. So +2 and -2 will cancel with each other, and so I just have subscripts 1 and 1, which means you don't have to write anything. So this is just going to stay ZnSO4. So just a reminder, when you see a single element plus a compound, that's going to be a single replacement reaction. So that's what we're focusing on. And when you have a single replacement, you have to use the activity series to determine, is that reaction going to happen? And if so, then predict your products. So first, we're going to put our smiley faces, our frowny face, and our star. Tin and sodium are metals. These are my 2 metals. So you'll notice that sodium is here and tin is down here. So sodium gets the smiley face, tin gets the frowny face. So we're going to put our frowny face there, smiley face here, and nitrate is the star. So nitrate wants to be with the smiley face, and guess what? It already is. So there is not going to be a switching of these two. So this is no reaction. Okay, the star wants to be with the smiley face, so this is going to be no reaction. Let's look here, and we have chlorine, and because chlorine is a halogen, it's going to switch with another halogen. So the Cl and the Br is what we're looking at now. And if you recall from earlier, on the periodic table, the halogens go fluorine, chlorine, bromine, iodine. So higher up on the list is the smiley face, lower on the list is the frowny face. So chlorine is higher. So here's my smiley, bromine is lower, so there's my frown. And then sodium is the star. Sodium gets to pick who's going to be with. Sodium wants to be with the smiley face. So that means these two are going to switch spots. So bromine is going to come over here and be on its own. Remember, I'm not carrying over subscripts. Plus, and then Na is now going to be with the Cl. Okay, so we do still have to balance charges and determine subscripts. So the question for bromine, since it's all alone, it's a single element, is it a diatomic? Yes, it is. So that means it should get a subscript of 2. And then for NaCl, I need to balance the charges, and so I'm going to have it written somewhere separate. Here it is. And I got to go look up the charges on my reference page. So here is sodium, it's +1. Here is chloride, it's -1. So +1, -1. Those charges cancel, and so I have subscripts 1 and 1. I don't have to do anything. So now that's just going to be Br2 plus NaCl. And you may be asked to balance the coefficients, but we'll worry about that during the practice section. So let's look at CaF2 and I2. Fluorine and iodine, those are both halogens, so they are going to be the ones to switch. Calcium's the star, fluorine is higher on the list, iodine is lower on the list, and look, we want to be with the smiley, the star wants to be with the smiley, so there's not going to be a switch here. This is no reaction. One more reminder that when you have a single element plus a compound, it is a single replacement reaction. Okay, so I'm looking at copper and silver, and I need to find them on the list over here. Copper is there, and silver is 2 spots below it. So copper gets the smiley face, silver gets the frowny face, and that makes carbonate the star. and the star wants to be with the smiley face, so these two are not going to switch. And so this is no reaction.